The equations of two lines are this and this. Show that these lines meet and find the coordinates of the point of intersection. Find the acute angle between these lines. Okay, let's have a look at this then. So this line meets this line. So here, let's have a look what we get. On the I components, we got 1 plus 2 lambda needs to equal 6 plus mu. And we've also got 2 on the j. We've got 2 plus lambda is equal to 8 plus 4 mu. And that's 2. So one of these, or two of these, take away one of those, yeah? So 2 times 2 minus 1 gives, and that will get rid of the lambdas and we'll get mu, won't we? 2 of these, take one of these, will cancel the lambdas. So 2 of these, 4, take 1 is 3. 2 of these is 2 lambda, take 2 lambda, cancels, that's why we're doing it. 2 of these, 16, take 6 is 10. 2 of these is 8, take 1 is 7, 7 mu. So that tells us that 7 mu equals 3 minus 10, which is minus 7. And that tells us that mu equals minus 1, doesn't it? So there's the value of mu. So 2 gives, now we can get lambda. Lambda equals 8 plus 4 mu. 8 plus 4 mu, mu is minus 1, minus 2, minus the 2. 10 minus 4, 8 minus 4 minus 2. 8 minus 6 is 2. In other words, lambda equals 2. So there's lambda and mu. Now let's check the k coordinate to see if the lines do in fact meet. So we've got the k component is going to be just 3 lambda, and that needs to equal 1 minus 5 mu. And that's a question mark. So what have we got? 3 lambda is 6, is equal to 1 minus 5, 1 plus 5, because mu is minus 1, which equals 6. So lines intersect, don't they? Because the k values are also the same. So the lines intersect at... Now what's the coordinate? Well, the x coordinate is 1 plus 2 lambda. Lambda's 2, so that would be 5. The j component is 2 plus lambda, wasn't it? 2 plus 2 is 4. And the k component was 6, wasn't it? So there's our point of intersection. Now it says find the acute angle between these lines. Well, let's use the dot product here for these two directional vectors. 2, 1, 3, 1, 4, minus 5. 2, 1, 3. Dot product with, I've just written its coordinates. 1, 4, minus 5. 1, 4, minus 5 is equal to, well, I'm going to write this as vectors, 2i plus j plus 3k dot product with I plus 4j minus 5k is equal to the modulus of this, which is use Pythag, 4, square this, square this, square this, and add them, and then square root the total. 4, 5, and 9 is 14. So that's root 14. This one, 25, 26, and 16, 42. Square root 42. Cosine of the angle between them. So that tells us that cosine theta then is equal to 2 times 1. 1 times 4 is 4. And then 3 5s are minus 15. Over root 42 is 3 root 14, isn't it? Root 3 times root 14, and there's another root 14 here. So it's root 3 times 14. Now I'm just going to check this again. the directional vectors. 2, 1, 3, 1, 4, minus 5. 2, 1, 3, 1, 4, minus 5 is fine. And I'm going to check the dot product here. 2, 4 is 6, and then minus 15. 6 minus 15 is minus 9. So it's equal to minus 9 over 14 root 3. Now the cosine CAST, cosine is negative here. So we got theta. Let's do shift cos on this then. So let's do shift cos. I'm going to drop the minus and I'll explain why in a minute. But shift cos of 9 divided by bracket 14 times the square root of 3, close bracket, close the cos, shift cos bracket, equals, we're in degrees mode, 68.2 degrees. So it's 68.2 degrees, and that was to 1 decimal place. And basically that's the angle, because although cos theta, call it theta dashed, because you've got your two lines, and this angle here, which was obtuse, is the theta, and this is theta dashed. So one of these, if I'd have worked out the other one, I would have got the obtuse angle here, but I want the acute angle. So between the two lines makes seems to be more appropriate, really. So it's 68.2 degrees. Let's go back to the question to check we're okay. Find the acute angle, there we are, between these lines. So that's fine.